हेलो स्टूडेंट्स, सो लास्ट वीडियो में हम डिस्कस कर रहे थे एसिडिक स्ट्रेंथ ऑफ फिनोल्स. नाउ लेट्स टॉक अबाउट सम रिएक्शंस विच सपोर्ट दैट फिनोल्स बिहेव लाइक एन एसिड. अब हम कुछ ऐसे रिएक्शंस डिस्कस करते हैं जो उसके उस एसिडिक नेचर को सपोर्ट करते हैं, राइट? सो इट्स अ वेरी स्मॉल एंड क्विक वीडियो वेयर विल बी डिस्कसिंग ओनली द रिएक्शन सपोर्टिंग द एसिडिक बिहेवियर ऑफ फिनोल्स, राइट बेटा? सो नेक्स्ट वन इज reactions supporting acidic behavior of phenols. एसिडिक का मतलब क्या है? फिनोल विल बी लिबरेटिंग H पॉजिटिव. देखिए, दिस इज फिनोल and if it liberates H positive, right? Let's say you put this in aqueous medium and if it liberates H positive which combines with water and forms H3O positive, because this is a weak acid, so we have put up this equilibrium sign. So this is phenol and this is phenate ion or phenoxide ion, and it has liberated H positive which has combined with the H2 molecule and formed hydronium ion, right बेटा? सो फिनोल का हम देखते हैं क्या क्या रिएक्शंस हैं. वो सारे रिएक्शन जिसमें फिनोल का सिर्फ H पार्टिसिपेट करे, वो सारे रिएक्शंस प्रूव करेंगे दैट फिनोल्स आर एसिडिक इन नेचर. ओके, सो लेट्स स्टार्ट देम विद देम वन बाय वन. लेट्स डिस्कस देम. इफ यू टेक फिनोल, if you treat phenol with sodium hydroxide, what will we be getting? This is a base, strong base, and this is a weak acid, right? So obviously this base will combine with H positive liberated by the phenol. So what happens? This forms sodium phenoxide because it has liberated its hydrogen, this hydrogen, and this hydrogen is combined with OH, right beta? Because when it liberates hydrogen, it liberates this in the form of H positive. So positive part of phenol combines with the negative part of sodium hydroxide, that is OH negative. So they forms, on combination they forms H2O, and this is ONA. So this is sodium phenoxide plus H2O. So because in this case H positive of phenol has gone, so this proves that phenols are acidic in nature. Next reaction, what happens when we treat phenol with, this is phenol, if you treat phenol with, let's say, Grignard reagent, if you treat this with Grignard reagent CH3MgBr, methyl magnesium bromide, the product we obtain would be O. Hydrogen of this goes with methyl of this, right? This goes in the form of H positive and this methyl has acquired delta negative charge. They both combines and they form CH4 plus O. Oxygen combines with magnesium MgBr, right beta? So this is the gas which was liberated when this particular Grignard reagent combines with phenol. So next one is, if phenol combines with, let's say, acid chloride CH3COCl in the presence of pyridine. Pyridine, the structural formula of pyridine is this, right? It acts as a base. ये base का role play करेगा. So hydrogen H positive of this combines with Cl of this and they both forms HCl, right? Other than that, this oxygen will combine with this carbon. This, look at this, this structural formula is C double bond OCl. So when this is gone in the form of Cl negative, this carbon, this carbon combines with oxygen and it forms O, this oxygen, and then C double bond O. So COCH3, and name of this compound is phenyl acetate. So this is phenyl acetate. This is the common name. If you write its IUPAC name, this is phenyl ethanoate, right beta? So this is the product. What is the role of pyridine over here? Pyridine is acting as a base, right? We know that phenol is a weak acid. Phenol is a weak acid. So when it liberates H positive, obviously it will form HCl. HCl is an acid. So this acid, pyridine, what pyridine does? Pyridine combines with HCl, this base combines with HCl, and the concentration of product side decreases. If concentration of product side decreases, then according to Lee-Chatelier principle, the reaction goes into forward direction. So role of pyridine is to consume HCl so that the concentration of product decreases and the reaction goes into forward direction. So this side will be writing the role of pyridine. Because pyridine is a base, it is a base. Combines with HCl, it combines with HCl. Forms a salt. एक salt बनाएगा HCl के combine करके. Concentration on product side decreases, right? So according to Lee-Chatelier principle, reaction goes into forward direction. Reaction shifts in forward direction, right? And that is our product. Purpose to get the product. So this way we can get phenyl acetate, and this is the role of pyridine. This is the role of pyridine. Next reaction which supports the acidic behavior of phenol is, let's talk about the next reaction, and that is when phenol combines with acetic anhydride. So CH3CO, COCH3. This is phenol and this is acetic anhydride because this is derived from acetic acid. So this is acetic anhydride. In the presence of CH3COONA, sodium acetate. Now here also sodium acetate is a combination of a strong base and weak acid. It's a salt of strong base and weak acid, right? So it will be liberating NaOH. NaOH means the basic component is stronger. So let's see what will be the role of this. In this case, how this liberation take place. This H positive combines with this one and it forms CH3COOH, means acetic acid, right beta? And the second product is O combines with this and this again produces phenyl acetate. So here the major product is phenyl acetate and this is acetic acid, right? So again in this case, this acetic acid being acidic, this combined with, because you are having basic medium, so that combined with the base, concentration of product side decreases and equilibrium shifts into forward direction. Next reaction is when phenol combines with benzoyl chloride, PHCOCl. So this is benzoyl chloride. When this combines with benzoyl chloride in the presence of aqueous NaOH. NaOH की presence में जब इससे combine करेगा, so how the groups leave hydrogen of this and Cl of this in the form of HCl. किस form में निकल जाएंगे बेटा? HCl की form में, right? And this produces the phenyl part of the here, then oxygen and this oxygen and then C double bond OPH. So look at this, this is ester functionality like in this case. So this is phenyl benzoate, and this particular reaction is called Schotten Bauman reaction. Schotten Bauman reaction, right beta? So in this case when phenol combines with the benzoyl chloride in the presence of basic medium, again the role of NaOH is same. This combines with HCl, concentration of product side decreases and the reaction goes into forward direction. So all these are the reactions which suppose the acidic nature of phenols. Phenols are acidic although they are weak acids, and we have already discussed why phenols are acidic in nature, right beta? So this way you can say that phenols are acidic, and if any of the conversions come into your examination, like if you have to convert phenol into phenyl benzoate, you just go with this reaction, Schotten Bauman reaction. Okay beta?